So I guess thank you to everyone who's stayed for the displacements round table. We do have some seed questions to discuss. We have 4 chairs and 2 seats. So I guess we could share microphones.
Plus the audience is going to do the talking, right?
Yes, absolutely. We're hoping that you guys are going to do most of the talking. We've tried to come up with some questions that encompass the various themes that came up in both of the sessions on displacements and deformations. It was quite a disparate group of talks on quite a lot of different things, but hopefully we can pull out some common themes and some recommendations to feed back to ISA. So the first question that we had was, which recommendations does our community give to ISA in this domain? So what targeted R&D activities in the short, the medium term, what do we need, what can we do in preparation for biomass, Roselle, Harmony, Sentinel-1 next generation to support the future of what we're trying to do?
That's your cue.
If I can kick off the discussion, in some of your presentations, there were already some clear recommendations. So for example, the observation continuity. So talking about Roselle, Harmony, Sentinel-1, NG, I guess we are already talking about the future programs that should ensure the continuity, which was anyway one of the key objectives achieved with Sentinel-1 compared to ERS-1, 2, and Envisage. So that's certainly one point that emerged from several of the presentations.
Yeah, I fully agree. That's definitely important for the Sentinel next generation. So to have continuity, not just the same frequency, but it's like the same orbits and compatible data, that time series can be continued. With the other missions, it's a little bit more open. I mean, you can try things with Harmony, and it has first to be tried and developed, and then really how to make best use of it will be possible to decide. So maybe more flexibility is important on the agency side. And with the L-band, there is already quite a lot of experience, and then with NISAR there will be much more experience probably before the launch of Roselle. And so there it's a little bit a question if it should just be another mission, or if it should split the responsibility between the different missions. So there may be even considering not just decisions by one agency, but by the JAXA, NASA, and ESA would be helpful if best use of the great times with a lot of L-band data could be made. So maybe something along this line, like coordination between the agencies for the L-band operations might be something we could state.
Maybe following up on that, Urs, you had some recommendations today, and you showed some very interesting work using L-band. Next year, our friends across the ocean are going to be launching NISAR. This is a perfect opportunity to, of course, experiment with L-band before Roselle. Can you think of any particular way that ESA can support us in that?
So I think one of the very important aspects is the availability of the data, and I think that should be great if it's what is promised. And then to have somehow good data, which means for these applications time series, and that should also be guaranteed without intervention. So maybe what may be helpful is some budgets for some groups, for some research, but I'm pretty positive that even without this will be done. So I think it's a quite good situation, but maybe to direct a little bit some questions. I don't know. It may still be helpful to have some possibilities.
I would recommend to do more research on ionospheric corrections if you're going to be dealing with L-band data. This is very important. I'm not sure whether Roselle is going to have the extra band that NISAR is going to have to better do the ionospheric corrections with the split spectrum method. But that's something that you should be looking into if you're going to be using L-band data.
Just to answer, so I'm involved, I'm not ESA, but I'm involved in the development of the GP-ROM prototype processor. I know they are foreseeing also this dual band, so dual chip transmission. They're just using the full 85 megahertz. Not necessarily for all subswaths, but for all of them. So in the others, they will use a larger bandwidth, which will give enough sensitivity then for ionosphere. And I heard from the presentation this morning that an ITT will be issued about ionosphere in the frame of Roselle this year. So I confirm the first 2 points.
Okay, so perhaps we can move on to the next question then, and that's... Yep, good point. Does anybody have anything to add about
Maybe
biomass?
I can say something. So somehow politically it is more correct at the present to sell missions as targeted. So there will be this global biomass map and so on with this accuracy. And I'm missing a lot the aspect it's just a new frequency, and so we can do a lot of nice tests and developments of algorithms for different applications, the ones that have been named, but also the ones that have not been named may be interesting. So there, I'm sure there will be good access to the data, but maybe to have the possibility to propose some small studies to investigate something would be fruitful, and also to somehow on ESA side collect the ideas or collect, like having a workshop. Things like this could be very beneficial to accelerate a little bit the understanding of what can be done, and different groups can motivate each other in showing results over one surface versus another one.
Any more comments on biomass or anything else we may have missed on that first point before we move on? Okay, so I guess the second question is, for people who were in the first session, I touched on it a bit in my talk, but what requirements are there for the smaller scale applications? So things like small scale infrastructure, mining, places where elevation changes very quickly through time, but much down at the small scale. And how do those use cases compare to the big earth and environmental applications where we're looking at continent scale, global scale, country scale? What are our different use requirements if we're looking at building scale or site scale things?
Well, maybe one of the reasons of this question was that maybe the community of geologists interested in large-scale phenomena is dominates a little bit. So we would like to ask if there is any way to accommodate the two types of requirements for the two types of communities.
And also, I believe, based on what we have seen today, that a way to accommodate these different needs is also working with contributing missions. Because if we talk about small-scale infrastructure, building stability assessment, for example, Sentinel-1, we all know does not perform as other types of SAR missions in terms, for example, of height estimation of the position of the persistent scatters, for example. So I believe that the accommodation could come, of course, if we continue investing in the complementarity between Sentinel-1 and all the contributing missions, and also we have seen today that the newly coming contributing missions like ISI is also providing further add-on to the current capabilities. So let's continue along this route.
Okay, this is a very quiet crowd. So let's move on to the third question. In situ instrumentation, ground-based radar, auxiliary data. What can we gain from these? How can we use them in our studies with satellite data? Just a general question out to the audience. Any suggestions? Anything we need more in terms of support for ground-based systems? Anybody in the room besides Urs who uses ground-based radar?
I think it's very complementary. So it's somehow the answer is already in the question. So it's important in the sense that it is very complementary. So with the satellite data, for example, for landslides, you get an overview over active cases. But if it gets dangerous, you want to have a more immediate access to the information, and so you put maybe an alarm system with where ground-based radar can be an element, but there are other elements, cameras and traffic light that blocks the road if the rock starts falling down, because there's half a minute time until it reaches, and that may be enough. So it's different responsibilities for the two things in this case. And so I think it's really nicely complementary and not in competition with each other so much. But there is overlap, so one can be used maybe to optimize the other one, or to validate some information, or to get different components of a motion over a landslide or a mine or so. So there's many possibilities, and both should be definitely done, and it's really complementary.
So maybe we can say, continuing what we said before, that maybe Sentinel, very large scale, then contributing X-band missions go to smaller scales, and ground-based measurements, even smaller, even more detailed. So there is this kind of complementarity. Yeah.
I don't see it as a scale thing. Also, I mean, to
Not
look
only
at
as a
more
scale,
detail,
yes.
you saw L-band results and you look at details. So you don't necessarily need the high resolution sensor, but maybe you need it. So it's again complementary, but it's not that one resolution is only supported by the spaceborne. It goes, even the Sentinel type resolution goes quite in a detailed scale.
Yeah. Also, not only the space resolution, there is also the temporal, the temporal sampling.
An
This
archive is another important aspect, which is more difficult with the high resolution, with the private run missions. You don't have these nice archives typically. So there maybe they can learn a little bit from Cosmo or TerraSAR, who do a little bit of archive, or who do, I mean, a lot of archive, but it's still difficult to have good archives ready if there's a process starting to become dangerous or important.
I think that what you said also is very important. Of course, we are all aware that the complementarity sometimes is hampered by the fact that ground-based systems are certainly not accessible as satellite data are. So probably this question about complementarity should also bring us to discuss how to, if there's a way that ESA can help with that, how to increase the accessibility of these facilities, because otherwise they would be confined to small case studies rather than a more common approach.
In addition to ground-based INSAR, are you including ground-based corner reflectors as part of this question? Or
By all means.
Yes.
By all
yeah,
means.
so that's a whole. We had several talks about how to use the corner reflectors to better determine where things are. So I think that's clearly part of this. I thought that was part of this question, but it wasn't clear.
Yeah, just to be clear on that, by ancillary information, we basically mean anything else that we would not want to use with it, whether or not it's ground-based or other satellite systems, anything.
Yeah, and probably this morning we saw also one talk specifying how, based on empirical data, how to better plan and task how to position corner reflectors, because it's pretty well established across the community how to design this component on the ground, but probably we are still far away from common guidelines. Basically, because there are only few groups using corner reflectors, is not yet probably something that is shared across the community. So another recommendation could be, for example, investing on projects that favor validation using corner reflectors and at the same time defining guidelines.
So jumping back to the second question a bit there, and sort of speaking a bit further to the resolution question of the ground-based radar, really the demand for, in the small-scale infrastructure, the demand is always going to be resolution, which is not really something that the big global missions can do. So we need to be asking almost a slightly different question of sort of, are there things that we can do with existing large-scale mission to optimize it so that we can use it in edge cases for small-scale infrastructure? And there it's looking for things like data availability, data subsetting, being able to just pull out little pieces of the data rather than downloading the entire data set. As you said, baselines, some diversity in baseline at some point during the mission. and I'm sure there are other things like that out there. But if we just ask what do we need for small scale infrastructure, the answer is always going to be resolution to start with. But that's not really the domain of these global missions that ETH is launching.
You bring up a good point about being able to pull out smaller amounts of data, because of course, right now, if you want to process a small area, you have to pull out an entire frames with 27 bursts and so on. Even going down to a burst level would make things much easier if you had a burst size products. But of course, data cubes would be nice. What about moving towards what is planned for NISAR, which is these geocoded SLCs? Would that make life easier for people here? That's controversial, but there are some advantages in terms of ability then to access smaller.
Usually in these smaller scale environments, the elevation models aren't good enough, as Rachel was saying earlier. The geocoded SLCs aren't going to perform as well. So that's kind of the worst of both worlds, really.
Right. But at least access to burst level would be proper.
Absolutely. And that's not going to happen with the Sentinel missions, but we should be planning for things like that with the future missions.
And we also saw a very good, interesting presentation earlier this week from Descartes Labs, where they have basically indexed a global index of all the SLCs, and they themselves are able to reach in and just grab the bits they want simply by indexing it. That could be perhaps something that was supported by ESA.
Providing that data retrospectively for the Sentinel archive would be very useful.
I think we should move to the next slide. So the fourth question is, what are the main issues for making INSAR more operational and respond to user needs? For example, is more important revisit time, spatial resolution, or other features?
If I speak with our surveying authorities, which have the intention to set up some monitoring system in Baden-Württemberg, then they ask, will be data available in the long future? So I think it's clear that you all want this, but I wanted to state it explicitly. For disaster response, it's revisit time is the key, and latency of processing. So that's especially a problem now that we only have Sentinel-1A.
Yeah, I think not only for disaster response, I mean, for monitoring any kind of motion, revisit time is really probably, I mean, resolution is good enough already. Also including the other missions, the X-band missions. So revisit time with the same angle, so interferometric revisit time is the issue.
Yes, which could be achieved either in constellation mode or with the flexibility and agility of the same mission. Because if we talk about global scale missions, of course, the observation scenario is mostly fixed. So it's just a matter of having more satellites working together in a constellation rather than for missions that are designed, again, as constellations, but to work in a flexible way. So here, probably, we have two main routes to achieve the revisit time, which I do agree with Mario. It's pretty crucial in most of the deformation and displacement type of applications.
I think considering also the private or national initiatives, just stating that short enough baselines is relevant is important. We have plenty of examples of the newer satellites where this is not assured, and so you cannot use it. And that makes a big difference. So, of course, so you have maybe nice parameters concerning the resolution and so on, but you cannot serve the user needs if it's not baseline suited for interferometry with ground motion information.
I would also, I think, confirm what came out of previous fringes, that if you're looking for something that's operational, then the routine and the boring, making things as boring and regular as possible is probably the way to go. I don't think that's changed.
Well, if, I don't know, if there are no other point on this, there is the question number 5, which is very different from the other questions. It's about if we think that it's important to invest in post-processing to extract information like warnings and alarms about stability of infrastructure, landslides, whatever it is. I mean, to bring this information in a way that is more easily accessible by end users, or which I think is the case, or if on the contrary, we are okay with providing measurements.
Yeah, so I'm thinking also about false positives in this sense, because we've seen a talk earlier today about DEMs and the relevance of them being up to date. And let's say you raise a tailings dam, you might show in your INSOR results that there's something going on here, even though, well, there is something going on, but it's planned and it's okay, right? Like, it's been raised, something has been happening, and your dam might not be up to date. So your INSOR results might show that, well, there's something to be concerned about, right? So you might raise an alarm or a warning, even though if you then talk to the people on site, you will find out that actually there's nothing to be worried about. So while it is a nice goal to strive for, I think it's tricky to do this without like talking to the people involved in the assets that are being monitored for these alarms.
Yeah, in fact, I think this is an extremely difficult task. So, and in fact, related to this is the other question, because I think it's very hard to pass from measurements to warnings, or so. This would require really a lot of research and effort and fundings from agencies like ESA. We are far away from this, I think. But I don't know what is.
Yeah. And also we need to engage with users because, for example, in Italy we have made several projects at national level to basically identify thresholds that are relevant to the users instead of defining top-down thresholds based on purely a scientific approach. Because in the end, you warn someone about something. So the main actor should be the someone you are going to warn, and that would be the clear point in my opinion. So investing in this aspect means also creating a way to engage with final users. And in this way, I guess, we can also solve the issue of false positives, because sometimes we just look at the data, see changes that are actually unrelated to the type, for example, of structural behavior of the object that is managed by the users. So I guess it's also an aspect of engaging users in the full process, so training them in understanding what we could provide, but basically they should be the designer of the warning system rather than just passive user of it.
Just quick question, who are those users you're talking about?
Sorry?
Who are those users you're talking about?
For example, in the cases that I was mentioning, where institutions, for example, those managing historical buildings in city centers, so they wanted just to know if satellite data could help them to prioritize restoration interventions. And sometimes what INSAR shows is just the normal behavior of the structure, especially if it's an ancient one. And so defining a threshold, for example, just converting the experience gained, for example, with modern architecture does not suit at all the purpose. Other type of users, for example, are ministries in charge of managing through their regional authorities infrastructure. We saw several case studies in the presentations with regard to motorways. Again, that's the type of user we are targeting, and in particular the technicians and the technical offices that are by statutory rules in charge of making monitoring and surveillance routinely of all these infrastructure, and satellite data could be one of the layers, the informative layers that they should use to come up with a reporting stating whether then the infrastructure needs further investigation or not. So these are the main users that we have interacted with.
And this aspect is related also with the success and the diffusion, the spreading of this technology, because you know, if we want that this technology become really used by many people, we need to make a step to make this information useful for the users, the final users that don't care about satellite interferometry. They don't even know what interferometry means. They want to know if a structure, an infrastructure, or a landslide gives some concern or not. And if we are able to make this step, the INSA will become a powerful and very much used instrument like GNSS is now. Otherwise, we remain confined in a small community.
I'm wondering whether this is, are you including EGMS as you're talking about post-processing of the EGMS data in this question, or is this post-processing of the basic Sentinel data? I wasn't clear what this question was about.
I don't know, I think also EGMS, but any kind of INSAR measurements. EGMS provide millimetric measurements, but who is going to look at all these millions or billions of measurements? No one. So if we could extract from this data some information for the end users. This is extremely difficult, but this will be, it is necessary to do this if we want that the decision makers, the governments, continue to put money in these satellites, because if it's only for the scientific community, at a certain point they will say, we put even too much money on this.
Mario, I disagree to some degree. I don't see it as our responsibility or as our task to go further steps, but we provide deformation information and quality for this information on this product. I see it more, Daniele mentioned in the same direction. So the user has to take this information as one of the several information sources, and it takes time that he trusts the information. So he needs cases he knows, and he sees that the cracks in the houses are where you see the gradients in the displacement. And so he starts to use it. But I don't think we should try to take over this role as well. Maybe very few are maybe in this other community, but most of us are more understanding interferometry to the level of the displacement map and quality of this information. And often I think it's good if you keep it this way. So in the landslide work in Switzerland, we don't try to provide the interpretation. Even so, we have geologists working with us, and they know the language. They have seen so many cases, so they can actually contribute a lot, but it has to be the Geoinformation Office or the natural hazard section of a province and so on who uses it. And it took 20 years. Now it's happening a lot. So suddenly it is really a very good situation, and they all want to solve questions with interferometry.
I agree, and also no one wants to take the responsibility of giving information that is difficult to give, because, and also this step must be done. I agree with you. We cannot do, the interferometric community cannot do this step alone. We need also the contribution from the geologists, the engineers, who are more in the.
I mean, I agree this step has to be done, but they have to feel they did it. Otherwise,
but I think we have to contribute, because we are the one that.
But they have to have the feeling they have made this step. That's my feeling from Switzerland.
That was actually up there, and then we will go to you.
Just to rebound off what you said, I think we should resist to compare INSAR and GPS or GNSS. I mean, that's and we will never achieve with INSAR what the market of GPS did, because we, as a scientist, we use GPS to look at the Earth deformation, but that's really a byproduct of what GNSS is. I mean, GNSS has been developed to localize the Earth surface on Earth, and that's something that everybody can understand, and everybody wants to know where they go and where they are. And with INSAR, we don't look at that, and that's why GPS has such a big market, because it gives this information. And as INSAR, we never provide something that's such interesting, so I don't think we should look for like having a growing market for end users. And the users that can be interested by our data are, as you said, like institutions for like monitoring for that infrastructure and public infrastructure. And the second big users are insurance company, but that private business, and basically we are giving away some like public money to private interests. And to me, it's like kind of problematic, because with our data, that can impact the owners of a house and all, and I don't know, I think it's kind of a touchy subject, and yeah, I don't feel very comfortable with that. That open, like we with public money, we open the full data, and it serves some like private interest in it. A lot of repercussion on like people actually.
No, just to complement. So if I'm before the break, we had a presentation where they are already working on these EGMS to produce this warning for buildings. So I mean, it's already going in this direction. So it's a post-processing, and they stated that this will be integrated in the chain. So this is already going in this direction. So the other question is, okay, this is 7 in this geohazards exploitation platform. As far as I know, they just produce interferograms. The question is if they want to produce more things. But anyway, the EGMS already is going in this direction. If I understood right.
Just to clarify, is geohazards exploration platforms also produce more than interferograms? So you can also access some tools to achieve PSI rather than SBAS. So just to make you aware of this.
So current,
This is the absolute last question. We're over time and they want to close it.
yeah, so currently in several German states, there are established organizational units which try to exploit INSAR data for their purposes. And I think there is still a need to help, maybe I should repeat it. So in Germany, there are currently several states establishing organizational units at the surveying authorities which want to exploit INSAR data. And there is still some gap how to exploit them in a useful way and to define products. And as has been said here before, to define products, there is needed the knowledge of geologists, engineers, and those people who do the practical surveying work at, let's say, bridges or roads. And I think it would be helpful if there would be funding for projects where INSAR experts and such stakeholders would work together to define products.
Thank you. Just one last comment then?
Yes, well, I'm an end user, okay? I'm a geologist working on tectonics, and I'm very interested by the way you process the data and everything. Just recently, there was a paper in Science done by 2 of my colleagues. I'm working in France, and it's about the GNSS. And they say that they have a signal, a pre-earthquake signal. So it's kind of a warning. And so it's in Science. So I don't agree with the comment that we should just restrain and just go just on the calculating displacement and period. I don't think this will be useful. And it's like you ask me also to just do my work, and then I'm not interested by what INSAR is. I am interested by INSAR. I even teach INSAR, so it's but I'm not a specialist. And then I think the 2 communities needs to mix together and prepare projects together even. I don't agree at all to this frontier or boundary between on one hand INSAR and on the other hand the end users. Thank you.
Thank you very much. And thank you everybody for contributing. And we'll see you tomorrow.
Thank you. Bye-bye.